Hey guys, welcome to another A Level Maths revision video. Today we're going to take a look at some exam revision. So a mix of topics. I've tried to pick a nice variety, but obviously without this video being about 2 or 3 hours long, I'm not going to be able to include all topics. So hopefully it will benefit you. I will timestamp which topics are featured throughout the video. So if you feel like you need specific help with one of the topics, just get through to that. But yeah, let's jump straight into it. So this first question was from a notoriously tricky paper. This was a June 2013 C3 paper. So this question is involving logarithms and exponentials. So 2 parts to it. So 6a, we want to find algebraically the exact solutions to these equations. So this first one just involves the natural logarithm. So we've got the natural logarithm of 4 minus 2x plus the natural logarithm of 9 minus 3x is equal to 2 lots of the natural logarithm of x plus 1. So this question is just testing your ability to spot the laws of logarithms, essentially, and work with them. So the first thing I spot here is the fact that it's 2 times the natural logarithm. I can take that up to the top using the power rule. So we can write that as ln 4 minus 2x plus ln 9 minus 3x is equal to ln of x plus 1 all squared. Okay. The next law here, a logarithms that I can use, is the product rule. So we can write this as a single logarithm as a product. So because we're adding them, we can write that as the natural logarithm of, so it's going to be 4 minus 2x times 9 minus 3x. Okay, and that's still all equal to this right hand side here, ln of x plus 1 all squared. Okay, now notice, because we've combined this one here, and it's just all as a natural logarithm, this is equal to a natural logarithm, we can antilog now. Okay, so if we antilog this, essentially we're just getting rid of the natural logarithms, seeing as they're both sides are just a natural logarithm. So what I get left with then is 4 minus 2x times 9 minus 3x is equal to x plus 1 all squared. Okay, now this is much easier to deal with. This is just something that you'd expect as a very, very hard kind of GCSE maths question. So if you expand both these brackets here, expand this, and then just solve. So expanding the left hand side first, that's going to give me minus 2x times minus 3x, that's 6x squared. We're going to get 4 times minus 3x, so minus 12x. Minus 2x times 9, so minus 18x. We'll also get plus 36. 4 times 9 is 36. And that's going to be equal to this side expanded, so this one's much easier. We get x squared plus 2x plus 1. Okay. Taking this all onto one side now, set this equal to 0 and then just try and factorise, hopefully. So that's going to give me 5x squared minus, so that'd be minus 30x and then taking over 2x off to give us minus 32x, and then 36 take 1 would give us 35 there. Okay, and this is all equal to 0. Now they won't always factorise these kind of equations. With it obviously being A level maths, sometimes you might have to use quadratic formula or completing the square, but in this case here we can actually factorise this. So it's 5x minus 7 times x minus 5. This is all equal to 0. So in that case, we get 2 solutions. We get x equals 5, so x equal to 5, and we also get, so solving this one here, 5x minus 7 equals 0, we get x equals 7 over 5. Okay, so that's that part A done. Part B now, again, just practicing the laws here of logarithms and exponentials. So let's take a look at it. So part B here. So we've got 2 to the x times e to the 3x plus 1 is equal to 10. So we need to show that it can be given, basically the answer can be given in the form a plus ln b divided by c plus ln d. So given that we've got powers here that are algebraic, the first step would just be take logarithms of both sides. Okay, so I take the natural logarithm of both sides here. We write that as the natural logarithm. So it's the product first, so 2 to the x times e to the 3x plus 1 So that's the left hand side, and do the same with the right hand side. Ln 10. Okay. Here now, where we've got this natural logarithm of this product, just like we're kind of unraveling it how we did part A, but this time we're going backwards. This time we're going to write it as the sum of these logs. Okay, so that's going to be the natural logarithm of 2 to the x plus the natural logarithm of e to the 3x plus 1. Okay. So just basically splitting them up, because what we can do now is we can basically simplify this one here because it's the natural logarithm of e, and then we can hopefully factorize and isolate x. So, just like we mentioned, this natural logarithm here of the exponential, remember this is just going to cancel to give me 3x plus 1. Remember the natural logarithm and e are the inverse, so they'll cancel. So what I get left here is, I'm taking this x down to the front using the power rule, so I get x ln 2 plus 3x plus 1 is equal to ln 10. Okay. What I can do now is subtract this 1 off here, so I'm going to get minus 1 plus ln 10. And that's going to be equal to x ln 2 plus 3x, and then we can factor that x out. That's going to be x ln 2 plus 3. Okay, so that's the first step there. And like we said then, just subtract 1 off both sides, so it's going to be minus 1 plus ln 10. I mean, but all we want is just x, so to obtain x, I just divide through by this ln 2 plus 3. So in that case, x is going to just simply be minus 1 plus ln 10 divided by 3 plus ln 2. So notice I'm actually writing it in the form they want it. Normally we would write this as ln 10 minus 1 rather than minus 1 plus ln 10. But because they want it as a plus ln b, for example, and c plus ln d, I've just given it in that form there. So that's a, that's b, that's c, and that's your d there. Okay, so 10 marks over off that question. Again, just practicing your laws for logarithms, exponentials, but hopefully not too bad. Next question now, a rather standard question, hopefully shouldn't cause too many issues. We're dealing with parametric equations, so a little bit on parametric differentiation, and then showing the Cartesian equation. So, if we want to find dy by dx for this one here, so question 5, what we need to do is we need to differentiate x with respect to t, differentiate y with respect to t, and then just do a little bit of manipulation. Okay, so let's just differentiate both of them separately first. So dx by dt, what's that going to give us? So the differential of x with respect to t would just simply be 4, because the differential of 4t plus 3 is just 4. Differentiating y now, so dy by dt, what would that give us? Well, that would just be 4. And this 5 over 2t, well, that's just going to differentiate to minus 5 over 2t squared. Okay? But you can think of it, if you prefer, as 5 over 2 times t to the minus 1, and differentiate it like that. Okay? So now we've got dx by dt, we've got dy by dt. We need dy by dx, though. Okay? So how do we get dy by dx using these? Well, you just got to do a little bit of manipulation. If you want dy by dx, well, notice this dy over dt, we need the dy on top, so that what we get for dy by dx is simply dy by dt times, so what we need now is dy over dx. Well, notice this is dx over dt, but if I flip this, the dt's would cancel and I get dy over dx. So dt over dx. Okay, just a standard result here. The dt's are cancelled, I get dy over dx. So, dy over dt, we know that's 4 minus 5 over 2t squared. And we're timing it by the reciprocal here, so times it by a quarter. Okay. So what would that give us? Well, what I could do here is write this over a common denominator. So it'd be 8t squared minus 5 over 2t squared. So let me try that out in full. So 8t squared minus 5. So that would be over 2t squared. But then don't forget we're timing it by 4, so it's 2t squared times by 4. So what I get is 8t squared minus 5 over 8t squared. Okay. We can simplify here. So treat this as an algebraic fraction. So you could write this as 8t squared over 8t squared minus 5 over 8t squared. So the 8t squared would cancel. So what this would give me is just 1 minus 5 over 8t squared. But what we want to know is the value of dy by dx at the point on t when t is 2. So when t is 2, so we just do it above. So when t is 2, we just need to substitute 2 into this. So what we're going to get is 1 minus 5 over 8 times 2 squared. Okay, so that's 1 minus 5 over 8 times 4, so 32. So 1 minus 5 over 32. And we could write that as 32 over 32 minus 5 over 32 to give us 27 over 32. Okay, so there we go for part A. That's just finding the value of dy by dx. Part B, again another standard question here. We want to show that the Cartesian equation of the curve C can be given in this form. So let's take it step by step here. Notice that we're writing this in the form y equals. So we've defined one of the parametric equations in terms of y. So we're going to use that. So what we need to do now is basically substitute t into it, because what we want is x. And this y here, so I'll just change my pen colour. So this y here is only in terms of x. Okay. Here, this y is involving t, but we can rearrange this here to be t equals like basically just involving x. When we sub it in, then we're going to get it in terms of x. So let's do that. Now, you could change it to be t equals for the x, but notice in our y equals, in our parametric equations, the fact that we've got 4t and 2t. And in our x parametric equation, we've got 4t. So basically all I need to do is rearrange in terms of 4t. So 4t is just going to be x minus 3. Okay, so x minus 3. Well, subbing this now into y, so y is going to be equal to 4t, so x minus 3, plus 8, plus 5 over 2t. So 2t is half of this. If you divide 4t by 2, you get 2t. So we divide this by 2. That would be 5 divided by x minus 3 over 2. So this would actually be 10 over x minus 3. Okay, just taking the 2 on top and times in it. Well, at this stage now, what I want to do is get this over a common denominator like they've done in their given form. So if I times everything through by x minus 3, we should obtain that. Okay, so this is going to be x minus 3 squared plus 8 lots of x minus 3 plus 10 all over x minus 3. Not quite sure why I'm putting the bottom one in brackets, but we'll roll with it. So if I expand this, that'll give us x squared minus 6x plus 9. We've got an 8x and then minus 24, so plus 8x minus 24. We also have our plus 10 here. Okay. Again, all over x minus 3. So if we clean this up now, what will we get? If we do it just above, what we're going to get then for y is x squared, because we've got no other x squareds, minus 6x plus 8x, that gives us plus 2x. We've got 9 minus 24 plus 10, so that gives us minus 5. And this is all divided by x minus 3 there. Okay, so your a is 2, and then your b is minus 5. But that's a very, very standard exam question. Make sure you're confident with both of these kind of parts, because if they come up really, really easy marks, you definitely want to be kind of guaranteeing those marks. So the next question here is a question involving geometric series. I'm basically looking at the idea of summations. So you're given formulas for this, and I've included them here in the top left. So you are given these in your formula book, but obviously just to help us through the video, I've included them here. So we're given a bit of information. The first term of this geometric series is 20, and R, the common ratio, is 7 over 8. So the first part wants us to work out the sum to infinity. So part A here, the sum to infinity. Well, the sum to infinity is given here at the bottom. A divided by 1 minus r. Well, let's just write down everything we've got. So we've got A, so A is 20, R is 7 over 8. So all we need to do is just plug that into this formula. Okay, so it's essentially just a substitution question. So 20 divided by 1 minus 7 over 8. So that, the denominator, will simplify to 1 over 8. So that's 20 divided by 1 over 8. And obviously you can take that 8 on top and times it by 20 to give us 160 over 1, or just 160. Okay. So that's the sum to infinity of the series. Part B then, we want to work out the sum to n terms where we're working it out to 12 terms. Okay, that's what we're being asked to do. So, again, just using the formula, this time we're using the top formula, because that's what we get for n terms. So, the sum to 12 terms here, so it's going to be A 20 times 1 minus, so it's r to the power of n, where n is 12 in this case. So we'll just write that at the top. N is 12. So this is actually 7 over 8 to the power of 12. Okay? And we divide this all by 1 minus r, so 1 over 8 again. Now at this stage here, this is just plug it into your calculator, see what you end up with. And if you do that correctly, what you should get here is 127.7 to 1 decimal place there. Okay? So part A, part B, pretty standard questions, nothing too tricky. Part C, definitely more of a problem solving question. So we're going to need a bit more room for this one, so if I clear everything first. Definitely not an easy question, so let's have a look at tackling it. So we're asked to find the smallest value of n, for which the sum to infinity minus the sum to n terms is less than a half. Well, we know what the sum to infinity is for this series. It's 160. Okay, so sum to infinity is 160 for this question. So what we're doing is 160 minus the sum to n terms is less than a half. Well, we can just basically make a little bit of manipulation here. I could subtract this half off, and I'm going to take this Sn to the other side if that makes sense. So what I'm saying then is that the sum to n terms has to be greater than 159.5. Okay, I'll subtract a half off both sides, and I'll take that Sn across to the other side. If we're saying 159.5 is less than Sn, then Sn has to also be bigger than 159.5. Okay, so it just makes it a little bit easier to work with. Now, the sum to n terms, we know is just this formula here at the top. So let's write that out. So what we're saying is A times 1 minus r to the n divided by 1 minus r is, oh sorry, wrong symbol, is greater than. Okay, so this is greater than 159.5. But let's plug in the numbers we know. We know A is 20, we know R is 7 over 8, and we know N. In fact, we don't know N for this one. So, this is going to be 20, 1 minus 7 over 8 to the N, divided by 1 over 8. Okay, and this is all greater than 159.5. So here, let's just keep simplifying this. So with this being 1 over 8, I can take the 8 on top. So what's this going to give me? So it's going to give me 160 times 1 minus 7 over 8 to the n, still being greater than 159.5. Okay. Here now, I want to keep simplifying. So let's see if we can get rid of this 160. So with this being 160 times this expression here, if I just divide both sides by 160, we're nearly there. So dividing both sides by 160, it's going to be 1 minus 7 over 8 to the power of n, and this is greater than 159.5 divided by 160, which I can write as 319 over 320. Okay, and we're nearly there now. Just keep simplifying here. So I'm going to do what we did here now with the Sn again. So we're going to take it over to the other side. So if I do 1 minus 319 over 320, that's going to give me 1 over 320. I'm making this positive now. So what I'm saying is, if I write it in full, it might be a bit easier to see. So 1 minus 319 over 320 is greater than 7 over 8 to the n. Okay, but if this is greater than 7 over 8 to the n, then 7 over 8 to the n must be smaller than it. Okay. Like so. So we're nearly there, still a little bit more to go. At this stage now, with it being a power, you need to spot the next step. And that next step is logarithms. Okay? So if I take logs of both sides here, so it doesn't matter what base you take the log to, I'm just going to take the natural logarithm, so base e. So I get the natural logarithm here. And don't forget, I'm going to take the n down to the front using the power rule. So I get n ln 7 over 8 is less than ln 1 over 320. Okay. Well, all we want is the smallest value of n. So all we need to do now is divide by ln 7 over 8. But you've just got to be so careful here. This is really, really common with these type of questions. If you divide by ln 7 over 8, plug this into your calculator and just check what value this is. And you'll notice that this is actually negative. Okay? So, because it's negative, remember the inequality sign will flip. So what we're saying then is that n is greater than, so just be very, very careful for that, ln 1 over 320, just right bracket so it's clear what's going on, divided by ln 7 over 8. Okay, and if you plug that into your calculator, you'll get n has to be greater than 43.198. But remember, we want the smallest value of n. Okay, so we can't give n as a decimal. It needs to be an integer. But seeing as we've already gone past 43, the next smallest value of n would be n equals 44 there. Okay. And there we have it. So 4 marks for that. Quite a bit of working. You just got to be very, very careful. This is the most important part to not trip over with. So just be very, very careful dividing by ln 7 over 8. Okay. So that's that question done there. So the next question, nice easy one here. Looking at our small angle approximation. So this is new to the new A Level Spec. And you are given the approximations here, okay, in the formula book. So makes these questions really nice and easy. Well, let's deal with the numerator first. So 1 minus cos 4 theta. So if cos theta is 1 minus theta squared over 2, then cos theta will be 1 minus, so it's going to be 1 minus, so where does a theta? Ours is 4 theta, so it's 4 theta squared. Like so, and we divide it by 2. Okay, so that's the numerator dealt with. The denominator is much easier. We've got 2 theta times, so if sine theta is approximately theta, then sine 3 theta is approximately 3 theta. Okay. The denominator will give us 6 theta squared. The numerator now, so it's 1 minus 1, so the 1's will just cancel. We've got minus this expression here. So essentially this is all positive now. So 4 theta squared is 16 theta squared, and we divide it by 2, so that would give us 8 theta squared there. And then simply, we just need to divide through now for the final line, our final line of working. So dividing both top and bottom by theta squared, we're going to get 8 over 6, and that would simply give us 4 over 3 there. Okay, so that's our final answer. 4 over 3 is our approximate value of 1 minus cos 4 theta divided by 2 theta sine 3 theta. So these questions, again, nice and easy. This is a very standard one, but it really can't get much trickier than this. So yeah, there we go. Next question now, again taken from the specimen paper for the new spec. We've got this integration here. So we're integrating t plus 1 over t between 2a and a with respect to t. Now we're told this is equal to ln 7, so we want to show that a is equal to ln k, where k is just a constant. So the easiest way I think to go about this is just split this up into two fractions. So we could write this as t over t plus 1 over t. Okay. Well, that would just simply be the integral then of 2 from a to 2a of 1 plus 1 over t with respect to t. Okay. So integrating this term by term then, the integral of 1 with respect to t is just simply t. So that's t. And then the integral of 1 over t with respect to t would just be ln t. Okay, and this is between a and 2a. Now we know this whole expression here is equal to ln 7. So all I need to do now is consider subbing in my limits, doing a bit of simplifying, and then seeing what value we get for a. Okay, so that's the idea here. We just want to see what value we get for a. So plugging in the limits now. So this is going to be 2a, t equals 2a plus ln of 2a. Okay, so that's my upper limit. We subtract the lower limit off, so minus a plus ln a. Okay, and we know this full expression is equal to ln 7. Now at this stage here, we just need to do a bit of simplifying. 2a minus a would just give us a. And then ln 2a minus ln a, what could we do with that? Well, we could write that as a single logarithm, right? So writing that as a single logarithm, that would be plus the logarithm of 2a divided by a. Like so, okay? Is equal to ln 7. But we can actually cancel these a's out. So the a's just cancelled to give us ln 2 here. So therefore, if we simplify and just isolate a here, solving for a essentially, we get a equals ln 7. Remember, this is just ln 2 now. So ln 7 minus ln 2. But a should just be equal to ln k, where k is a constant. So again, laws of logarithms. What about this as a single logarithm? So a is equal to ln of 7 over 2. Okay, because we're subtracting logs, we write that as a quotient. Okay, so a is just simply ln 7 over 2, where k is 7 over 2. Nice and easy. Another question done there. Nice and easy. Oops, we're going too fast. Right, so this question here, question 1, just a standard differentiation question here. So let's have a look at it. So this question is looking at the quotient rule, and I should have actually included the formula. We are given this in the form of the book, but let's try one out, see if we can do it. So f of x equal to 2x divided by x squared plus 3. Well, with this being quotient rule, what we should do is define u and v and go from there. So u, remember u is your numerator, so 2x. V is the denominator, so x squared plus 3. So if we differentiate u, differentiate v, and then apply the quotient rule. So u prime, the derivative of 2x is just 2. Derivative of v, that's just going to be 2x. Okay, differentiate 3, that's just 0. So at this stage here now, we just apply quotient rule. So apply quotient rule. So it is giving you formula if you can't remember it. But remember, to get the correct order here, we do 2. So we do u prime times v. So you've got to be careful with quotient rule. Product rule, it doesn't matter. Quotient rule, it does matter the order. So it's u prime times v minus uv prime. So doing that, that's 2 lots of x squared plus 3 minus 2x times 2x. So minus 2x all squared. And we divide this by v squared, so x squared plus 3 all squared. Like so. Okay. All I'm going to do here is just simplify this and just write what dy by dx is. So this will give me 2x squared plus 6. And then we've got minus 4x squared at the end there. and then we divide this full expression by this squared, which I'm not going to expand because you'll see why in a moment. So if I just simplify the numerator one final time, what we get is 6 minus 2x squared, and then we've got the same denominator as previously. Okay, and that's our dy by dx. Now the question doesn't just ask us for dy by dx, it asks for which values, or the set of values, sorry, of x for which f prime of x, so that's just dy by dx, being greater than 0. So if f prime x is greater than 0, we're just setting this greater than 0. So if we do that over here, so x squared plus 3 all squared is greater than 0. This is nice and easy now. If I just multiply through by this denominator, all I get then is just 6 minus 2x squared. Okay, obviously anything times 0 is just 0. So what we're saying then is 6 minus 2x squared has to be greater than 0. Well, solving this now, I could write this as 2x squared is less than 6, in which case we'd be saying, through, dividing through by 2, that x squared is less than 3. Okay, now we need to find the set of values for this. So in my opinion, it's easiest to draw a sketch here. So if I draw a sketch, it's a little bit all over the place, but just so you get the idea here. This would be x squared minus 3 is less than 0. So where is it under the x-axis? Well, if I draw a sketch of this graph, this would just be x squared translated 3 units down. And it's going to cut through the x-axis at 2 different places. It's going to cut through at minus 3 and, minus the square root of 3 and the positive square root of 3. So let's just cut it through. Let's just say it's that. So it cuts through here at root 3, and it cuts through here at minus root 3 there. So it cuts there, and it cuts there, and it cuts through there, obviously, at minus 3. Now all we care about is where is this less than 0, so where under the x-axis is it? So that's just here. So notice my interval then, my set of values would just simply between minus root 3 to root 3. Okay, so we can just define that interval there. Like so. Okay, so between minus root 3 to root 3. And this brings on to the very final question here. We've got an integration by parts. So I know this is everyone's favourite. It's definitely not mine either, so don't worry too much. We want to find the exact value of ln x divided by x squared between 1 to e. So this is quite a good question. It tests your understanding of integration by parts. And obviously we actually got an integral here involving the natural logarithm, so it always makes things a little bit more complicated. So for integration by parts, we need to define u, and we need to define v prime. So u and v prime. And then obviously we'll have a v and we'll have a u prime. So in this case here, we have to decide between ln x and x squared. Now the first thing is, how do we know it's integration by parts? Well, I can write this integral as a product, so it would be ln x times, so with this being 1 over x squared, we could write that as x to the minus 2 like that, okay, with respect to x. So this is now an integration by parts. We just need to pick u and v prime. So how do I know which one to pick for u, and how do I know which one to pick for v prime? Well, the big clue is the fact that we've got this natural logarithm here. Remember, integrating the natural logarithm is a nightmare, okay? That requires integration by parts itself. So I'm not going to pick that for my v prime. It would just be silly. I won't want to pick that to integrate again. So I'm going to pick ln x as u, because it's much, much easier to differentiate ln x than it is to integrate it. So in that case, that means 1 over x squared, or in other words, x to the minus 2 is my v prime. So in that case, I need to differentiate ln x to get u prime. So that would just simply be 1 over x. And we need to integrate v prime here to get v. So what's the integral of 1 over x squared? Well, that would be x to the minus 2. So if you integrate that, that would give us minus 1 over x. And there we have it. Now, the formula for integration by parts is given here, and it is in your formula book. Like I said, I just took everything from the formula book where it's needed. So we just need to apply this here. So this is uv, so that's ln x times minus 1 over x. So minus 1 over x times ln x minus the integral now of v. So what's v? So v is minus 1 over x minus 1 over x times du by dx, so my u prime here, so 1 over x. And obviously this with respect to x. Okay, so if we just start simplifying here, minus 1 over x times ln x, so that'd be minus ln x over x. With there being a minus here, now this will be minus 1 over x squared, but I can take that minus to the outside here using linearity, and because this is minus the integral, it'll become the addition of the integral, so this will become plus the integral of 1 over x squared dx. So at this case now, all I need to do is integrate this, and then we can start subbing in our limits. So I haven't forgot the limits, I know I've not included them just yet, but we will plug them in just at the end. So if we integrate this here, just like we did before, that's minus 1 over x. So my final integral then is minus ln x, so minus ln x divided by x. So with this being minus 1 over x, I can take that minus obviously back out, so it's going to be minus 1 over x, like so. Okay, and now we can put the limits back in. So our limits are 1 to e here. So all we need to do, plug our limits in, simplify, and we should get something of the form a plus b over e. So this is minus ln e, so let's just write everything out in full, minus ln e divided by e, minus 1 over e, minus 1 over e. I'll put everything in brackets so we don't get tripped up, and then we subtract off the lower limit, so this is minus ln of 1 divided by 1 minus 1 over 1. So if I simplify here, remember ln e is just 1, so this is minus 1 over e minus another 1 over e. So if we just simplify it here, that gives us minus 2 over e, and then we subtract off minus ln of 1 over 1, so that's 0. Remember ln of 1 is 0, so 0 divided by anything is just 0, and then we've got minus 1 over 1, so minus 1, but it's minus 1, that becomes plus 1, which actually gives us the result we need. So therefore this is the same as 1 minus 2 over e, and in that case a is 1 and b is minus 2 there. Okay, because we've got a is an integer obviously, and b is also an integer. So there we have it. So that brings us to the end of this video. I hope this has helped in preparation for any assessments you might be doing, any exams you've got coming up. If it has helped, please leave a like. If there is any issues throughout, again, just leave a comment. And yeah, cheers guys.